Hi everyone, in this video we are going to discuss gasoline. So gasoline is something you're probably really familiar with, especially if you're from the United States. We use it a lot here. We can use it to power our lawnmowers, we can use it to power our cars, our Hummers, our trucks. We use it fairly frequently. But actually we want to dive just a little bit deeper into it. We want to figure out how you actually get gasoline, where it comes from scientifically, the chemical background of it. But I also want you to tell me what gasoline actually is. I hope that you somehow someday know that. So the big thing is we need to know that when you talk about gasoline, you're actually talking about petroleum. And so petroleum is simply the liquid form of a fossil fuel, okay? But it is a mixture of hydrocarbons. And that's a really big thing to understand. I know that at least when I talk to people, they'll be like, oh, gasoline's just octane and da-da-da-da. And well, it's actually not. It's a mixture of hydrocarbons. And if we were to be very specific, you would know, or you could tell someone, that it's actually a mixture of the hydrocarbon when you have 5 carbons on your hydrocarbon all the way up to when you have 12. And so that specifically, that mixture of hydrocarbons is what we define as gasoline. So before I go any further on this and actually talk about how we actually get gasoline and where it comes from, I want to review a couple things. What is the name? Okay, so I'm looking for the name of the alkane hydrocarbon that has, so we'll just say with 5 carbon atoms. So that's my question. What is the name of the hydrocarbon, the alkane hydrocarbon that has 5 carbon atoms? Go. All right, did you get an answer? Hopefully you did. This is something you strictly need to have memorized. I've asked you to memorize all the alkanes from all the way up to 8 carbons, so this is one that you should know. That is, if it's ane, A-N-E, it's going to end A-N-E. If there's 5 carbons, then you use the prefix pent. Pentane is actually the word. All right, next question. What is the name of something that has 6 carbons? We're looking for alkane hydrocarbon with 6 carbons. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. If you didn't, though, please know that you will be expected to know this in the future, so I would definitely strongly encourage you to start working on memorizing these things now. But same method as before. It's an alkane, so we're going to end with A-N-E. There's 6 carbons, so we use the prefix hex, and so we end up with something called hexane. It's beautiful. You use it a lot in lab. It's awesome. It actually smells kind of cool, too. I'm the chemist. All right, so now there's the chemistry of gasoline, which is actually the important part of this video. Yes, the first thing that I want you to know about gasoline is what it's made of. I want you to know that it's petroleum, that it's a mixture of hydrocarbons from carbon 5 all the way through carbon 12. That I expect you to know. That's the first thing. But I also expect you to tell me what reforming is and cracking is. So let's work with reforming first. That's the first and the easiest one to talk about. But specifically, catalytic reforming. So let me give you a definition of it first before we can work through a quick little example. But basically, it's exactly what it sounds like. You use a catalyst, right? It says catalytic, so you definitely need to use a catalyst. And you're going to do this to conjoin, okay, several small linear, okay, all things are very important, small linear molecules to form a few larger molecules. And I'm going to put branched in there. Okay? So you're going from small to big. Anytime you hear the word reforming, especially in the context of gasoline, you know that you're going from small to big. So one of our best examples of that is if we looked at ethane, C2H4, and then we used a catalyst, right? So I'm going to put that catalyst there, and you take it from ethane to octane, so C8H16. Of course, you have to balance this. It's a chemist in me coming out. You got to do that. But this is a very, very common process. You take ethane, you add a catalyst to it, you break apart those small linear molecules, and you form a few larger branched molecules. Okay, this is a very, very, very common process. Now, the opposite of which would be catalytic cracking, right? Not reforming, but cracking. So catalytic cracking. And again, this is the opposite process. So here, you use a catalyst, but this time, you use it to break large molecules into small molecules. So it's literally the exact opposite. and it's a very, very, very common process. So usually, or a common one that you could use would be C16H34. Again, you use a catalyst. You need to write your catalyst above that arrow to remind people you had to add something there. This doesn't just happen spontaneously. So you actually add that catalyst. It breaks apart into two different octane species. So you can have C8H18 octane, and you can also have C8H16 octane. And so this is something super important. You need to be familiar with this, but I don't expect you to know that nitty-gritty part of it, the actual chemical equation, but you do need to know that definition. You need to be able to define what it is to use a catalyst. If for forming, you know you're going from small to big. If you're cracking, think cracking, you're breaking something in half. You're taking a large molecule, literally wrapping it in half, and then ending up with two smaller things. Now, there's also something called thermal cracking. I do want you to be familiar with it, but please know that it is not a very popular process anymore because it is ludicrously expensive. And so for thermal cracking, basically what you do is you use heat to break large molecules. Again, we're still cracking, so that's definitely going from large to small. So you break large molecules into small molecules. Okay. Now when I say heat, I want to give you just a little bit of context. Heat sometimes can be written with this little triangle. If you ever see that, that's saying heat. But in this context, we usually say something around 450 degrees Celsius. Sometimes you even go up to 500 degrees Celsius, but it just determines on your plant and your situation and a lot of other conditions in the environment. So a common example of this would be to take C16H34, break it apart using heat. So you just draw that little triangle there, and then you end up with C11H22 plus C5H12. But you need a lot of heat. So you have to take something, normally, remember, room temperature is 25 degrees Celsius. So you have to take that kinetic energy and add so much more thermal energy in order to increase that temperature to 450 degrees Celsius. It is ludicrously expensive, okay? So this is not a very common theme. So let me see. I had a picture of it somewhere here. If we can find it, keep scrolling, keep scrolling. Here it is. So here's a big picture of it. So just so you can kind of visualize it, when you have any type of cracking, you're taking a very, very large, long molecule, you're splitting it in half, and so you have two smaller ones. They're not always the same size. That's a common misconception. People are like, oh, they just split it right in half. No, that's not the case. We crack it, we break it apart based on a lot of different conditions, a lot of different parameters. There's always a weak point, and so this is very common. All right, so now, said a lot of different information here. Let's make sure we're all on the same page. My question is, which method of cracking, so method of cracking is the best? Go. All right, did you get an answer? Hopefully you did. It's very, very straightforward. We're talking about which method of cracking, so it has to be cracking. It's definitely not reforming. So the only options we had here for the word before cracking was either catalytic or thermal. Thermal, I told you, was ridiculously expensive, so the best one is definitely catalytic cracking, okay? So keep that in the back of your mind. Catalytic cracking is great. Catalytic reforming works pretty well. Thermal cracking, terrible. Not the best option. Have a great week. Take care of yourself. Drink water.